Hello, good morning. What do you call an old Spanish door? El door. All right, let's get to it. We've got a new topic. All right, so we are now doing relative frequency and probability. And yeah, essentially, we're predicting theoretical and experimental likelihoods. Okay, now this first lesson, all we're going to talk today about is the difference between a sample space and the number of outcomes. And I need you to be very careful because the terminology in these subjects is very, very specific. Okay. So if they ever ask you for a sample space, they're asking for the set, which is the key word here. It's the set of all possibilities. Whereas if they're talking about the number of outcomes, they're talking about the size of the sample space. Okay, now these two are very, very closely linked, but depending on what they ask for, you're going to have to answer a certain way. Okay. I'll show you just a couple of these. So it says list the sample space and hence find the number of outcomes of. And we're going to start with some single stage here. So if I just toss a coin, the way that I would do sample space is I'll just say SS. And then what I'll do is the curly brackets. And then if I'm tossing a coin, my two options are either heads or tails. And that there would be your sample space. Whereas the number of outcomes, and I'll just say size, or maybe I'll just write number of outcomes. Or, all right, total outcomes. There's two total outcomes, okay? So can you see the difference? If I'm asking for sample space, I want the specific outcomes. If I'm looking for the number of outcomes, I just count out how many different options there are. Okay, now if I roll a regular dice, sample space for this one, again, curly brackets. If I roll a regular dice, sorry for my curly brackets, my options are 1, 2, 3, 4, 5, or 6. And how many total outcomes are there? Well, there's a total of 6. Does that make sense? Now, even if we start to get into the multi-stage, so what this means is there's more than one thing going on. Some people will say this is multi-event. I just call it a multi-something. So if I toss a coin and roll a dice, what I'm going to give you a hint of here is it's helpful to draw it as a tree. Okay, so let's say the first thing is when we toss a coin, I've got two options really. It's either going to be heads or tails. And when I roll the dice, there's 6 options from each. 1, 2, 3, 4, 5, 6. Same thing here. Now, I know this isn't the most neat, but you get the idea. Now, with my sample space, now I want to quickly do this. That means I can get a head and a 1, head and a 2, head 3, head 4, head 5, head 6, or I could get a tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. Now, that there, I'm going to find a nicer way to do my curly brackets. This here is what I'd have to list if I was talking about my sample space. Okay, but here you can see that my number of outcomes, total outcomes, there's a total of, and if you count them up, there's 12. Okay, the easiest way to count that up is there's 2 options for the first, 6 options for the next event. So that means 2 times 6 will give you a total of 12. Okay, so that is that. When you start getting multiple things going on, often a good thing to do is to draw some type of tree. Okay, now the last one that we have for today, talking about the sample space and number of, what is it, sample space and number of outcomes. I want you to be very specific here because we're talking about the sum of 2 dice. Okay, that means I throw 2 dice and then I add the numbers together. Now, there's a slight difference between if I was to do like what happens if I get 2 dice, because I could get 1 and 1, I could get 1 and 2, I can get 2 and 1, I can get 1 and 3, 3 and 1. So there's so many different options, but if we're talking about the sum, I'm just caring about what happens when I add the two numbers together. Now, I'll give another hint here for something like this, because I don't want to have to draw a tree that's got 6, and then each one's going to have another 6. That's going to get real messy real quick. So if there's two events, such as throwing a dice, sometimes the best way to draw this is to use a table, and your table is going to look a little bit like this. Okay, so I'm going to have 1, 2, 3, 4, 5, 6. I'm going to do the same thing here, 2, 3, 4, 5, 6. And what's going to happen here is as I add each of these up together, that means 1 plus 1 gives me 2. All right, 1 plus 2 will give me 3, 4, 5, 6, 7. And then I could keep going here. This would be 3, 2 plus 2 is 4, 2 plus 3 is 5. And you can see that it just follows a pattern, so on and so forth. And you can see that all the way towards the end, 6 plus 6 will give me 12. Okay, so if I'm talking about my sample space, because I just care about the sums, that means essentially I can only really get 2, 3, 4, 5, 6, 7, 8, all the way up to 12. 12 is my highest number. Okay, so looking at this one, how many different total outcomes are there? Well, counting each of these two, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 total outcomes. If I was just to talk about the, 11 total outcomes in terms of what different sums I can get from 2 dice. Okay, now hopefully that makes sense. Good luck, all the best, and I'll catch you in the next one. See you later. Bye.